Hello class, welcome to this video on the Chapter 11 test. So we're going to cover the questions from a version of the test, which means that your version may differ, if you happen to have retaken the test. But most of these questions should be on point as far as, the concepts and for you to kind of review in case you need to do the test corrections and stuff. So for Chapter 11 test, which of the following solids can be shown to have the same volume by using Cavalieri's principle? All right, so in this case, since we're talking about Cavalieri's principle, remember that Cavalieri's principle stated that if you have any two solids, say this solid, and even something like that's completely different in shape, maybe like a triangular prism, perhaps, or maybe a square prism. So let's do a square pyramid. Let's do a square pyramid. And as long as the area, so if I take slices of this, right, take this slice at this level, and this cross-sectional area here, shown in purple, is the same, that's area, which is the area of a circle, is the same area as the area of this square, which it could be, depending on the dimensions of the shape, right, of the particular shape. If those areas are the same, then that must mean, and they're the same at every point in the solid. So at every cross section, I find the area, and if the area happens to be the same, right, at every level, which we know it's not going to be the case here, but that's besides the point, and that's because the shape here gets smaller as you go up and up on this pyramid, right? But let's just assume that this is going to be the same area at every point, and the heights are the same for both solids, then that must mean that the volumes must be the same. Now, we said that that argument falls short in this example because the square actually gets smaller, right? And the circle does not get smaller. So there's no way that they can have the same area. But that's besides the point here. This is just for demonstration. All right, so that's the idea of the Cavalieri's principle. So in this case, a right rectangular prism with a cross-sectional area B and a height h. Okay, so let's draw all these shapes out. So we got a right rectangular prism, so which we'll draw that one out first. So let me get rid of this graphic here. So we got a right rectangular prism. And the cross-sectional area is B, so the area of that is B, and the height is H for that prism. The next one is a right cylinder with a cross-sectional area of B, so that area is still B. That's basically what we were saying, if the cross-sectional areas are the same and the heights are the same. So if the heights are the same and the cross-sectional areas are the same, then the volume of both of these shapes should be the same, and in fact they are. The volume of both of these solids is BH, right? So that looks good so far. A pyramid with a base area of B and a height of H. Now they're talking about the base, not the cross-section, right? So they're talking about this base here is B and the height is H, but we know that can't be true because the size of the base, well, this base is the biggest it can get, and when you take cross sections above the base, the square actually gets smaller, or the rectangle in this case, and so this is not going to work here. And it doesn't even say it's a square pyramid. It could be any shape. It doesn't really matter. It gets smaller as you go up, so that's not correct. A right rectangular prism with a cross-sectional area of 2b and a height of h over 2. So it's the same thing as this, but half the height. So it's half the height, but twice the cross-sectional area. Now, even though it has twice the cross-sectional area and half the height, the volume of this particular pyramid, or this particular prism rather, is 2b times h over 2, which is still bh, right? The 2's cancel out. Even though the volumes are the same, that is not Cavalieri's principle, right? Cavalieri's principle states that the heights have to be the same and the cross-sectional areas have to be the same at every level. So even though the volumes are the same here, this is not because of Cavalieri's principle. This is because of the simple mathematics, that if you have twice the base area and you have half the area or half the height, then it just happens to cancel out. This is not Cavalieri's principle. So therefore, this is not going to work. We're not going to include that in our response. An oblique cylinder with cross-sectional area B and H. So oblique cylinder. The cross-sectional area is B, and the height is H. And the answer is yes. The volume of this cylinder is BH by Cavalieri's principle, right? Because it's the same as this cylinder here by Cavalieri's. They have to be the same. If they're the same height and the same cross-sectional area everywhere, which they do, then by Cavalieri's principle, that's the volume. So that is correct. Okay, so for the next question, find the volume of a cylinder with a base area of 121 pi inches squared. That should say inches cubed, by the way, not squared. Oh, actually, no, that's correct. They're talking about the base area, not volume. They want you to find the volume with the base area. So the base area is 121 pi, and the height is equal to the radius. Okay, so the formula, remember, you may recall, for the cylinder is capital B times, H, right? And I use capital H, but you can use lowercase h. I like to use capital H here. And we know that this capital B is the same thing as pi r squared, right? For the area of a circle, because you're talking about a cylinder here, and the base area is a circle. All right, so we want to find we know that the height is equal to the radius, and so we can plug in r for that. However, we need to know the radius, and so we're going to plug the 121 pi into B. So 121 pi equals pi r squared, and the pi's cancel, leaving us with 121 equals the radius squared. Take the square root, and so the radius is 11. Okay, so now we can go ahead and plug this in. This is 121 pi, and the height is equal to the radius, so I can replace the height with 11. And so if I did that, I would get 121 times 11, which should be 1331. We'll type it in here. Yes, it is. So we got 1331 pi inches cubed. And so the answer is A. All right, so for the next question, which solid revolution is produced by rotating the shape below? So you want to rotate this about this axis here. 360 degrees. Describe or sketch the solid generated. So if I rotate this rectangle of 360 around, then I will get a cylinder. As you can see here, I can take this and rotate it everywhere. And so we can see that we have a cylinder such as D. All right, so for the next question, each side of a cube measures 3.9 centimeters. Its mass is 62.4 grams. So we know the mass. And we know we technically know the volume of the cube, because the cube is, it's going to be width times height, length times width times height, right? Or I like to call it just base times height for the base of the bottom, and the times the height of the prism. And so it's just basically a 3.9 by 3.9 by 3.9. So the volume of this cube is 3.9 to the third power. And to find the density of the cube, the density is the mass divided by the volume. So we just plug in the numbers. 62.4 over 3.9 cubed. And we get about 1.05 grams per centimeter cubed. Now for the next question, find the volume of the solid. Now this is a square pyramid. Now the volume of a pyramid is 1/3 times the base area times the height, and we can see that the height is 15 centimeters, and the base area is an 11 by 11 square, which is 121 centimeters squared. So we're going to plug that in. We got 1/3 times 121 times the height of 15, and we know that 15 divided by 3 is 5, and then you could do 5 times 121. Now 5 times 120 is 600, and then you can just add the 5 in there. So it should be 605. So you get 605 centimeters cubed. All right, so what is the approximate volume of the figure shown? Round to the nearest tenth. Now this is a sphere, so the volume of the sphere is 4/3 pi r cubed. We just plug it in. The radius is 7, so we got 7 cubed. So 7 cubed is actually 343. So you got 343 divided by 3. You could multiply this by 4 and then divide by 3. So 343 times 4 is 1372. So we got 1372 pi over 3. And then so we could just plug it in the calculator and see what we get. So we got 1372 times pi divided by 3. So about 1437 feet cubed. Find the diameter of a sphere with a volume of 2304 pi. So we know that the volume of the sphere, we did that earlier. That was pi r, 4/3 pi r cubed. Let's plug this in for our volume. So we got 2304 pi. And so notice that the pi's cancel out if they're on either side. They basically go away. So we can ignore them here and just focus on the numerical part. And to get rid of the 4/3, we need to multiply by 3 because it's being divided here. This r cubed is being divided by 3. And so if we multiply by 3, it'll cancel out naturally. And this r cubed is being multiplied by the 4, so we can divide by 4 to get rid of it naturally. And we're going to do the same thing on the other side. And so r cubed, so we can do 2304 divided by 4, which it is divisible by 4. And you get 576. And you can do 576 times 3, which is 1728. There you go. And then we can do the cube root of 1728, which I'm not sure how I would do the cube root here. But we can try it and see if it works. No, that's okay. So we got 1728. We're going to do the cube root of both sides. Now you can do this on the calculator, and what we'll do here is should be a decimal. We're going to see which one is works for that. If we did 16.6 to the 3rd power, does that give us 1728? Let's see here. Nope, that gives us 4,000. So let's do 12 to the 3rd power. And yes, that gives us 1728. So that means that the radius is actually 12. It actually worked out perfectly. 12 centimeters. All right, find the volume of a square pyramid with base edges of 48 centimeters and a slant height of 26. So we just got to be careful. They give us the slant height, right, which is 26 centimeters, not the actual height of the pyramid. And they give us the height is 26 centimeters. So, or no, sorry, not the height, the base edges. So they give us the base edges are 48 centimeters. So it's a 48 by 48 on the bottom. All right, so the volume of a pyramid is 1/3 BH. Now B is the square on the bottom, right? The square on the bottom, which is 48 by 48. So we got to do 48 times 48. Let's go ahead and plug that in and see what we get. 48 squared is 2304. So let's plug that in for B here. So we get 1/3 times 2304 times height. Now we don't know what the height is, but we're going to use a Pythagorean to do that. We know the hypotenuse. We know we actually need to find the height, right? And we do know this bottom side. This bottom side is half of 48, which is 24. And so we can use the Pythagorean theorem to get h here. So we get h squared plus 24 squared equals 26 squared. So h must be the square root of 26 squared minus 24 squared. So let's do that. 26 squared is 676. 24 squared is 576. So this is going to be the square root of 100, which is 10. All right, so now we know that the height is 10, so we can plug that in here. And we know that this is divisible by 3, so you can actually divide that by 3. So 2304 divided by 3 is 768, and then 768 times 10 is 7,680. And so there's your volume. Okay, so for the next question, describe the cross-section below. So the cross-section you can see is this guy being shaded, and you can see that there's 1, 2, 3, 4, 5 sides, so it is a pentagon. It's a weird looking pentagon, but it's a pentagon nonetheless. And that's because of the weird angle of the cross-section. The cross-section is angled in such a weird fashion that there's this little side sticking out there. All right, so the next question, find the volume of a cylinder with a base area of 169 pi, so that's the capital B, which we know is equal to pi r squared, and the height equal to the radius, so the h is equal to r. So let's find the radius here like we did in that one other question. So this is equal to pi r squared, the pi's cancel, take the square root to get your radius, and that's going to be 13, because 13 times 13 should be 169. I will double check that, of course, just to make sure, because I do make mistakes. So that's 13. And it says the height is equal to the radius, so this is equal to the height. And you want to find the volume. So the volume of a cylinder is BH, and then we got B is 169 pi, and then the H is, well, 13. And then we just plug that in. So we got 169 times 13 is 2197 pi. And they do have it in terms of pi here. It's going to be D. All right, find the surface area of the following solid. The height of the triangle is 7 square root of 3. All right, so you could actually find this height on your own, but I wanted to give you a little hint so that you can find the height of the triangle, without having to worry about trying to, actually find it. But you could find it since it's an isosceles triangle, and you should be able to do that. However, I gave it to you. So let's go ahead and do the surface area. Now the surface area of this is based off of, well, you have two triangles of which I gave you the height, and the base now. So the base is 14 of the triangle, and the height is 7 square root of 3. So you can find the area of that triangle. So the surface area is the area of those two triangles plus the area of the three rectangles. Okay, so we're going to add up those here, and then I'll do this in purple. Okay, so the area of a triangle is 1/2 base times height. So we got 14 times 7 square root of 3. And that takes care of the two triangles. Now that's only one triangle, so let's double it to get two triangles. So that's my two triangles, 1 and 2. Now for this rectangle here, it's a... So this for this particular rectangle, it's a 14 by 15. So we're going to do plus 14 times 25. I said 15, so 14 times 25. And there's two of them, right? So the one on the left and one in the front, one in the back. So there's two of them, so I'm going to put a 2 there. And then I'm going to do the one on the bottom. The one on the bottom is a 14 by oh, actually, now that I think of it, yeah, so now that I think of it, they're all the same. All of these are the same, so I'm going to color this purple as well. This is also going to be a 25 by 14, because this is an equilateral triangle. So I'm going to multiply by 3 instead, and then that'll take care of it. So we'll do that on the calculator. Notice that the half and the 2 cancels out there. So we got 14 times the square root of 3, or times 7 times square root of 3, and then plus 3 times 14 times 25. So we get that, about 1219.7. All right, Mario's company makes unusually shaped imitation gemstones. One gemstone had 12 faces, so F is 12, and 10 vertices. V is equal to 10. So remember that Euler's formula is F plus V equals E plus 2. And so if I do 12 plus 10, that can give me the number of edges, and that's what they want. So this is 22 equals E plus 2, so E has to be 20. 20 plus 2 is 22, so 20 edges. All right, find the volume of a right rectangular prism with a length of 11, width of 10, and a height of 8. Volume of a rectangular prism is pretty easy. Just do, use LWH, or you can use capital B, capital H. It's the same thing. 11 times 10 times 8 is the bottom line. So 80 times 11, so 8 times 11. So it's going to be 880 centimeters cubed. Find the volume. The height of the triangle is 7 square root of 3. So this time, instead of doing surface area, we're considering the volume. So we still need to know the area for the volume. So the volume of a prism is capital B times capital H. The capital H here is the 25. That's the height of that prism if you were to stand it straight up, you know, if you were to stand it nicely. Or the depth of the prism, I guess you could say. Now the area of this cross section, this triangle here, is 1/2 base times height. So capital B is 1/2 base times height, little b, little h. And now you know why I use capital B, capital H. So the little b is 14, so 1/2 times 14, and then the little h is the 7 square root of 3. And half of 14 is 7, so you got 7 times 7, so you got 49 square root of 3, and that's your B. So your volume is 49 square root of 3 times the height of the actual prism itself, which is 25. So we'll multiply those together and see what we get. 25 times 49 times square root of 3. So about 2121.8. All right, find the volume of the cylinder. So the volume of the cylinder is capital B times capital H, the base area, which is the area of this circle here with a radius of 5. Now the area of a circle is pi r squared. So really this is just pi r squared h. Okay, so pi is just pi, the radius is 5, and the height is 14. So we got 25. So we got 25 times pi times 14. So we get 25 times 14, which is 350. So we get 350 pi. You can, of course, compute that as a decimal, but here they have it in terms of pi, so there's our answer. Find the surface area of the cone. Now, the surface area of a cone is the part that wraps around, which is pi times radius times the slant height, plus the base on the bottom, which is pi r squared, right? So, and the radius of this is 9. So we can plug that in for 9 both here and here. Now the L, we have to actually find the L, and that's the slant height there. Now we know the actual height, and so we can use the Pythagorean Theorem to use the radius, the height. So let's use the Pythagorean Theorem. So we get L squared is equal to 26 squared plus the radius squared, so 9 squared. And then we could take the square root to get rid of that. And so we can do that on the calculator and get L. So it's going to be square root of 26 squared plus 9 squared, which is 27.5. And we'll plug that in there. Now the answer is in terms of decimals. We're plugging everything in. So we get pi times the radius, which is 9, the slant height, and 9 squared. So plug all of that in, and we'll plug it in at once. And we get a little over 1,000, 1,032-ish. All right. And so the answer is, about 1,032 pi r squared and pi r L. And so it looks like it's not actually matching up with one of these. And so that means there's a typo in this question. So I went ahead and, if you had this question, give you credit accordingly. I curved the tests to help with that. But yeah, so the answer it's actually none of these. The answer is given over here. I believe maybe the answers are based off of whether it was a volume or not. I'm not entirely sure, but it should say 1,032 for one of the answer choices. All right, so now actually this is a volume question, pretty similar. So let's see if one of those were actually the volume. Well, here these are different numbers, so we'll find out, I guess. So the volume of the cone is 1/3 pi r, 1/3 BH, right? It's still going to be 1/3 BH, but B is pi r squared. So it's pi r squared H, because the B is this bottom, which is the area of a circle. So we got 1/3 pi times 9 squared, and the height is 26. So we'll plug that in. This should be an easier calculation. And we got 2205. So that one actually worked out. Let's see if that's one of our answer choices. It's not one of the answer choices, so there's something inherently wrong with the question, with the answers in that question. All right, so find the volume. So we got the volume of, so this is an oblique cylinder, but we know by Cavalieri's principle that the volume must be the same as a right cylinder with the same height and the same radius, right? So the volume of the cylinder is still going to be the same. It's going to be pi r squared h, right? We're going to use capital H instead of lowercase, but you get the idea. So if capital H is 5 and the radius is 4, so we get pi times 4 squared times 5. So we got 16 times 5. So it's going to be 80 pi. And 80 times pi is 251. So it's going to be this answer. All right, find the surface area of a sphere with a circumference. So they give you circumference. Round to the nearest tenth. So if the circumference is 13, now the circumference formula is 2 pi r. So we can use that to find the radius. So let's do that now. So we got 13 equals 2 pi r. So we'll divide by 2 pi. And that'll be our radius. And let's go ahead and round that. Actually, let's leave it like that. I'm going to leave it like that, 13 over 2 pi. Now, the surface area of a sphere is 4 pi r squared. So we're going to plug that in for r. So we get 4 pi times 13 over 2 pi squared. So we get 4 pi times 13 squared, which is 169, over 2 squared is 4, and then pi squared is obviously just pi squared. So the 4's cancel. Notice that one of the pi's here cancels because there's 2 on the bottom, and you get 169 over pi. And that's your volume, or that's your surface area. So let's go ahead and plug that in. And so the surface area is about 53.8 millimeters squared. All right, so the surface area of a cylinder, recall there's 2 circles, right? So there's this one and then this one. So it's 2 circles, so it's 2 pi r squared. And then the part that wraps around is the circumference of a circle times the height, right, of the cylinder. And that's your formula. So we got 2 pi times 5 squared. I believe that's a 5 there. Yep. Plus 2 pi times 5 times 14. So we just plug that in. Now, it's not in terms of pi. So 5 squared is 25 times 2 is 50. And then 5 times 2 is 10. 10 times 14 is 140. So this is going to be 140 plus 50, or 190 pi. Now, if pi is about 3, then 3 times almost 200 is roughly 600. So it's going to be close to 600. Let's go ahead and actually figure out what it is. Yeah, 596, close to 600 as I mentioned. All right, so the volume of a sphere is 1928 pi. So that's the volume, and we know that the formula for the volume is that. So let's plug that in for the volume. So 1928 pi. Notice that the pi's cancel, so we can just kind of ignore them. And to get the radius, well, we're going to need to get rid of the 4/3. We did this before. We multiplied by 3, divide by 4. Okay, now 1928 is divisible by 4 because 28 is divisible by 4. So 1928 divided by 4, so it's 482. And we get 482 times 3, which is 1446. We get r cubed equals 1446. Then we take the cube root of that. And again, you need to find a number that if I cube it, I get 1446. And so that'll give me my radius. Now it should be, hopefully it's a nice number. Let's see, 14 cubed is actually too big. And 12 cubed is actually too big. So this is going to be a decimal for sure. So what I'll do is I'll actually plug it in the calculator. And I'm just using the basic calculator that's on you know, any standard PC. And so I'm going to hit second. There's the cube root function. So cube root, okay, so we got to type in a number first. So we got, the number was 1446, and then the cube root, let's hit that. So 11.31. So, okay, so we'll say that, 11.31. And then we'll plug it into our surface area formula because we want to find the surface area. Okay, so surface area of a sphere is 4 pi r squared. So now we can plug in this and square it. And we'll go ahead and type that in. We can type that in here. So we got 1607-ish. So there you go. A solid composed of a right cylinder and hemisphere is shown. Find the volume to the nearest tenth. So the volume total is the volume of the hemisphere plus the volume of the cylinder. Now the volume of this hemisphere is 2/3 pi r cubed. That's half of that of a sphere. And the radius of this cylinder, which is the same as the radius of the sphere, is 2, right? The diameter is 4, the radius is 2. So we're going to do 2 cubed. Plus the volume of the cylinder is pi r squared h. So pi times 2 squared times 7. And so 2 cubed is 8. 8 times 2 is 16. So this is 16/3 pi. This is 4 times 7, or 28 pi. Let's go ahead and add all of that together. So we got 16/3 times pi plus 28 times pi. We get 104.7 centimeters cubed. Find the volume of the oblique cone shown in terms of pi. So the volume of an oblique cone is the same as the volume of a regular cone by Cavalieri's principle, with the same height and radius. Okay, and here I believe, let's make sure that this is the case. No, they said that the diameter of this cone is actually 14, so the radius has to be 7. Okay, so the volume of a cone, remember, is 1/3 pi r squared h, and so we can plug that in. So we get 1/3 times pi times 7 squared times 27. And we got 1385. Oh, and they have it in terms of pi, so we got to do it in terms of pi. So let's just ignore the pi. And so that's going to be 441 pi. There you go. All right, so find the answer of the sphere with the given dimension. Leave your answer in terms of pi. Okay, so sphere, for the surface area of a sphere is 4 pi r squared, right? So we got 4 pi times, now the radius is 60, so you just got to do 60 squared. 60 squared is 3600, and so 3600 times 4. So 36 times 4 is 144. So this is going to be 144, and then 2 zeros, and then pi after it. So there you go. Find the surface area of this pyramid. So now this is a square pyramid, so we know that these 4 triangles are actually the same area. So we're going to find the area of those 6 triangles, and the area of the triangle is 1/2 base times height, right? So, and there's 4 of them. So the surface area is 4 of those triangles. The base is 5, and the height is 7. Now we also need to do the area on the bottom, which is the area of a square, or 5 times 5. So we're going to add that to 5 times 5, and that is our area. So we got half of 4 is 2. 2 times 5 is 10, times 7 is 70. So 70 plus 25 is 95. So 95 feet squared. All right, that's going to do it for the video, guys. So I hope you found this useful, and I hope you learned a few things, as usual. I'll see you in the next one.